Right, so this chapter I think will be included in your final. So for your test, I think still sama sampai alkene. Right. Okay, so these are the learning outcome for this chapter. Okay, for this chapter dia panjang sikit. Okay, because haloalkane boleh banyak reactions yang berlaku. Okay, so the first part tu benda yang sama lah. Okay, we will talk about the general formula for haloalkane and then classifications of the haloalkane, physical and chemical properties, draw and naming the haloalkane according to the IUPAC nomenclature, and then describe the isomerism, describe the haloalkane polarity, and then this one include in the reactions of haloalkane. Right. So the main reactions in haloalkane is substitution reactions and also elimination reaction. Okay, this one. Okay, so dua tu yang penting lah. So setiap reaction tu akan ada mechanism. So mechanism akan ada banyak sikit untuk this chapter. Okay, so let's see the first one, introduction dahulu. Okay, haloalkane are organic compounds containing one or more carbon halogen bond, which is CX bond. X is the halogen atom, okay, which is fluorine, chlorine, bromine or iodine. So the general formula for haloalkane is CnH2n plus 1 X. Right. So it is also called as alkyl halide, halogen substituted alkane, halogenoalkane or organohalogen. Okay, normally we use as haloalkane or alkyl halide. So all haloalkane contain a hydrogen atom, which are fluorine, chlorine, bromine or iodine. So in your periodic table, this halogen atom located at group 70. Okay, that attached to alkyl group. So alkyl group yang mana satu? Methyl, ethyl, propyl and so on. So the high reactivity of haloalkane can be explained in terms of the nature of CX bond. Okay, so you can see here CX bond. Okay, so you can see difference in electronegativity between these two atoms. Okay, which is highly polarized covalent bond due to the large difference in the electronegativity of carbon and halogen atom. Okay, so inside here we can see the CX bond, so different in electronegativity. So carbon is more positive compared to chlorine. So that's why carbon is partial positive and then chlorine is partial negative. So chlorine is the negative end of the bond dipole. Okay, and then carbon is positive end of bond dipole. So you can see the dipole moment positively signed here akan duduk dekat carbon, and then the arrow towards the more electronegative atom. Okay, so kalau nampak dekat sini, yang bulat ni is the electron density. So we can see the electron density at chlorine is higher or bigger compared to the carbon here ataupun methyl group dekat bawah ni. Okay, yang ini electron density lagi besar compared to methyl group. Right. So right now we move to the classifications of haloalkane. Macam mana kita nak classify the haloalkane into primary, secondary and tertiary. Right. So it depending on the number of carbon bonded to the carbon with the halogen atom. Okay, you can see here. Okay, let's say we have the carbon dekat sini. Okay, this carbon pegang halogen. Okay, but then this carbon tak pegang another carbon. So we call it as this one. Tak ada classification lah. So the name will be halomethane. No classification for this one. Okay, tengok yang sebelah sini. Right. So in the middle here we have the carbon. Okay, you look at this one. Okay, this carbon bonded to the halogen. Okay, how we want to classify the haloalkane? Okay, tengok carbon yang pegang halogen tu, that carbon pegang carbon yang lain. Okay, ada berapa carbon lain yang dia pegang. So this carbon bonded to only one other carbon. So meaning that one is primary haloalkane. Okay. Second, carbon that bonded to halogen. This carbon bonded to another two carbon. Okay, that one is secondary haloalkane. So carbon that bonded to halogen, this carbon bonded to another three other carbons. Okay, another three carbons. Okay, that one adalah tertiary haloalkane. So meaning that classifications of the haloalkane will depend on the number of carbon bonded to the carbon with the halogen atom. Okay, dekat berapa carbon yang pegang halogen tu pegang carbon yang lain. So yang itu adalah dia punya classification. Kalau dia pegang satu, so primary lah classification dia. Okay. Okay, let's see this example. So let's try to classify all these haloalkane.
Madam,
Ya,
slide madam tak tukar.
slide tak tukar.
Dia stay dekat introduction.
Baik. Alright, wait. Okay, nampak tak?
Tak.
Okay, boleh ke?
Dia introduction.
The introduction. Right now,
Nampak.
classifications of haloalkane.
Ya.
Nampak? Boleh?
Boleh.
Okay. So again, for classifications of haloalkane, to classify as primary, secondary and tertiary. Okay, it will depend on the number of carbon bonded to the carbon with the halogen atom. Okay, so sekarang kita tengok kat sini. Yang ini tak ada carbon. Okay, semuanya hydrogen. So no classification. So we move to the next. Okay, this carbon bonded to carbon yang pegang halogen. Ataupun kita cari dulu carbon yang pegang halogen tu. Okay, this carbon bonded to how many another carbon yang lain. Okay, how many another carbon. Kalau dia bonded to one another carbon, so that one the classification will be primary haloalkane. Okay, next, carbon that bonded to halogen. This carbon bonded to two other carbon. Okay, meaning that one adalah secondary haloalkane. So the third one, carbon that bonded to halogen, this carbon bonded to another three other carbon. Okay, meaning that one adalah tertiary haloalkane. Okay, let's see this example. Okay, if we expand the structure, we can see. Okay, so kita cari dulu carbon yang pegang halogen. And then this carbon bonded to how many other carbon?
One.
Okay, so meaning that the classification will be primary. Okay, same goes to this carbon. Okay, the next pula. Kita cari dulu carbon yang pegang dengan halogen. And then this carbon bonded to another two carbon. Left and right. So the classification will be secondary. Kalau tak boleh nak nampak, you expandkan dia punya structure. Okay, the tertiary. Okay, carbon yang pegang halogen. So this carbon bonded to another three carbon. Okay, tiga carbon yang lain. So meaning that the classification is tertiary. Okay, so easy saja for classification. Next, we move to the physical properties of the haloalkane. So physical properties ada banyak in terms of the boiling point, solubility, and also density. Okay, let's look at the first one. Physical properties of haloalkane compound will depend largely on these two, which is the first one is its mass, the second one is the polarizability. Mass ni bergantung kepada berat dia lah, berat compound tu. Okay, kita tekankan hanya untuk halogen atom itself. Okay, mass of the halogen. Kalau kita tengok, going down the group, the size getting bigger. Okay, size tu makin besar. So mass tu lagi tinggi lah ataupun makin berat. Okay, kalau polarizability, okay, how to explain polarizability? A measure of the ease of distortion of the distributions of the electron density about an atom in response to interaction with other molecule and ions. Okay, distortion meaning that macam ada sedikit kecacatan, okay, of the distributions of the electron density about an atom in response to interact with another molecule or ion. Okay, meaning that here fluorine has a very low polarizability. Meanwhile, iodine has a very high polarizability. Okay, kenapa? Okay, dia akan depend between these two. Okay, let's see. So trend in polarizability. Smaller particles are less polarized than larger one because the electrons are held more tightly. In this case, that's why fluorine dia ada low polarizability. Okay, kenapa? Sebab dia punya mass ataupun the size of the atom is smaller. Okay, smaller particles. So kita ada, let's say kat tengah ni adalah nucleus. Okay, kat tepi ni adalah dia punya electrons valence. Okay, so kalau dia punya size tu kecil, the attractions between nucleus with the valence electron will be stronger or weaker?
Stronger.
Stronger. Okay, so elektron tu akan pegang lebih kuat. Okay, tarikan antara nukleus dengan valence elektron akan lagi kuat. That's why the polarizability will be lower. Okay, polarizability maksudnya easy to distort. Okay, bila dijumpa atom yang lain, contoh kita ada HF dengan HBr. Okay, so we can see here different in electronegativity. Hydrogen is partial positive and fluorine is partial negative. Same goes to this atom. Partial positive, partial negative. Okay. Right. So I draw the electron distribution. Okay, hydrogen, dia punya electron distribution is smaller compared to fluorine. Okay, here smaller compared to bromine. Okay, kenapa these two dia punya electron negativity berbeza? Okay, kalau kita tengok sebabkan the size of the fluorine is smaller. Okay, so bila dia jumpa hydrogen, dia punya distortion tu akan jadi kurang. Okay, sebab electrons valence dengan nucleus dia pegang kuat. So susah untuk dia lepaskan valence electron tu nak form another bond with another atom. Okay, kalau bromine, the size as we going down the group of 17, the size getting bigger. Okay, so dia akan ada high polarizability, easy to distort. Okay, nampak je atom yang lain positively charged, senang dia nak tertarik. Like this one lah. Kalau yang F ni, dia senang juga nak tertarik because positive and negative, it will attract each other. But then, dia punya tarikan antara nucleus dengan valence electron tu stronger, so susah untuk dia nak distort. Okay, nak form a new bond tu agak susah. Okay, so in going down the group, the polarizability will be increased. Okay, so it will depend on these two. The first one is the mass and the second one is the polarizability. The point you boleh beritahu yang the first one tu it depends on the size of the particle. So polarizability increase going down a group because atomic size increase and larger electron cloud distort more easily. So lagi senang dia nak form a new bond. Dapatlah positive and negative. Yang ini bila dia dah form a new bond, contoh kat sini hydrogen, ini adalah fluorine ataupun bromine ataupun fluorine. Right. Okay, the first properties is boiling point. Okay, for an alkane and haloalkane of comparable size and shape, the haloalkane has the higher boiling point. So we see these two examples. We have the same number of carbon, 2, 2. But then this one ada bromine. So bila ada bromine, kat sini kita boleh nampak different in intermolecular forces. Okay, IMF berbeza. Dekat sini kita cuma ada non-polar compound. Okay, non-polar maksudnya dia punya electronegativity lebih kurang sama. Carbon, carbon. Right. In here, we have different in electronegativity. Carbon partial positive, bromine partial negative. So the IMF right now will be hydrogen bonding. Hydrogen bonding, electronegativity is higher. No, intermolecular forces is higher compared to the London dispersion ataupun yang dekat sini, weak van der Waals. Okay, that's why in haloalkane, okay, with the same number of carbon, if you have halogen atom, okay, so dia punya boiling point akan jadi lebih tinggi because you want to break the intermolecular forces, so you need more energy. So the boiling point will be higher. Okay, so boleh nampaklah kat sini negative 29 degrees Celsius. Meanwhile, for haloalkane with the same number of carbon, so the boiling point is 39 degrees Celsius. Okay. Next. Okay. The low boiling point of fluoroalkanes are the result of the small size of fluorine, the tightness with which its electrons are held to the nucleus, and their particularly low polarizability. Okay, in this case, okay, we have alkane and also haloalkane. Okay, kalau yang tadi kita cakap bila kita ada alkane dengan haloalkane, ada je haloalkane, so haloalkane ni boiling point akan jadi lebih tinggi. Okay, because we have different in intermolecular forces. Okay, but then this one, okay, we still have difference in intermolecular forces. Okay, yang ini kita ada structure of alkane saja. This one we have haloalkane. Should be with the presence of the haloalkane, dia punya boiling point lebih tinggi compared to alkane. But this time around kat sini dia berbeza. Kenapa? Okay, you look at the halogen used. Okay, in this case dia guna fluorine. So fluorine, the size of the atom is smaller. So bila size of the atom smaller, the attraction between nucleus and the valence electron is stronger. Okay, so dia explain kat sini lah. The small size of the fluorine, the tightness with which its electrons are held to the nucleus. So therefore, dia punya polarizability is low. Even though you ada halogen inside your alkane, but then you punya halogen tu akan mempengaruhi juga you punya boiling point. Kalau kat sini dia tukar kepada chlorine, okay, so meaning that the boiling point of this haloalkane will be higher compared to your alkane. Right, so is it clear? For these two boleh beza yang ni dengan yang ni.
Boleh.
Right, so next, we still with the boiling point physical properties. Okay, boiling point increase as the size of R increase. So meaning that kalau you ada more number of carbon, okay, so yang lagi banyak you punya carbon tu, lagi tinggi you punya intermolecular forces, so you need more energy to break the forces. Okay, so boiling point akan jadi lebih tinggi. So due to the stronger intermolecular forces of attraction, the surface area of the chloropropane is larger than that chloroethane. Okay, sini ada dua carbon. So the halogen here is chlorine. In here you have another one carbon which is propane. So propane that bonded to chlorine. So as the number of carbon increase, so boiling point will be increases too. Okay, due to the strong intermolecular forces. Okay, next, boiling point increase as the size of X increases. So going down the group, so the size of the halogen will be increased. So makin dia punya size besar, so dia punya boiling point pun lagi tinggi. So bromine is more polarizable than chlorine. Okay, so the forces of attraction, which is London dispersion, becomes stronger due to increase in molecular size and its mass. Hence, the boiling point increases. So we have the same number of carbon, 2, but then we have different halogen, chlorine and bromine. So going down the group of 17, we have fluorine, bromine, iodine. So in terms of the size, Okay. Right. So polarizability yang bawah ni lagi higher compared to chlorine. So kalau chlorine, that's why dia punya boiling point lagi rendah compared to bromine. Right. So in terms of the size and also polarizability juga. Okay. So next, among constitutional isomer, branch isomer have more compact shape. So decrease in area of contact ataupun surface area. So decrease van der Waals attraction forces between the neighbor and lower boiling point. So right now we have the same number of carbon 1, 2, 3, 4, 1, 2, 3, 4. Yang ini adalah isomer kepada the straight chain here. Okay, but then kenapa straight chain lagi higher boiling point compared to the isomer? It depends on the surface area ataupun contact area. So the branch isomer lagi less boiling point compared to the straight chain alkane. Because yang ini dia punya surface area ataupun contact area is smaller compared to the aliphatic. Yang straight chain punya. Okay. So that one is the first physical properties. We move to the second physical properties, which is solubility. Okay, solubility maksudnya kita nak tengoklah dia soluble tak in water ataupun soluble tak dalam organic solvent. Okay, so the haloalkane are only very slightly soluble in water but dissolve in organic solvent. Organic solvent boleh jadi polar ataupun non-polar. It depends. Okay, so in this case haloalkane very slightly soluble in water. Meaning that kalau kita buat eksperimen, kita campurkan haloalkane dengan water, kita still akan nampak two layer. But then the two layer tu tak clearly seen. Kena ada bubble-bubble saja. Okay. So this is because for dissolving haloalkane in water, the strong hydrogen bond present in the latter has to be broken. So when dissolved in organic solvent, in this case, non-polar solvent. So the intermolecular attraction are almost same as that being broken. Okay, to make it clear kat sini, kita imagine kita ada HX. Okay, HX. Okay, meaning that kat sini kita ada haloalkane. And then we have water molecule. The molecule which is H2O. Okay, H2O. Okay, ada dua lone pair. Okay, so sekarang dekat haloalkane ni dia ada intermolecular process yang sendiri. Okay, inside water pun dia ada intermolecular process yang sendiri. Okay, so the intermolecular process will be attracted. Yang ini partial negative, yang ini partial positive. So the intermolecular process form adalah dekat sini. Okay, positive negative different electronegativity, maksudnya kat sini dia punya intermolecular process adalah hydrogen bonding. Okay, same goes to water. Okay, water will be attracted. Sini partial negative, partial positive. Okay, so here. Okay, also hydrogen bonding. Okay, before these two mix together, maksudnya kita nak masukkan haloalkane inside the water. Okay, sekarang dekat haloalkane and water, kena putuskan dulu dia punya intermolecular process. Each of it. Okay, kat sini kena breakkan dia punya intermolecular process. Here dia kena breakkan intermolecular process. Okay, to break the bond, okay, ataupun to break the intermolecular process, kita kena undergo exothermic ke endothermic? Bond broken, what process form? What process needed? Endothermic or exothermic?
Endo.
To break a bond, absorb heat or release heat?
Absorb.
Absorb. So we'll undergo endothermic. Okay. Bond formation, nak form a new bond, we need to release heat. So exothermic reaction. Okay, what happened here? Okay, kita nak breakkan dia punya intermolecular process. Okay, nak break bond broken. So kita kena undergo endothermic. So endothermic energy needed here is tinggi lah, higher energy needed. Okay, kat sini higher energy. Same goes to yang bawah. Okay, we need to break the forces here, so higher energy needed. Okay, kalau kita nak form a new bond between these two, which is between HX and H2O. Okay, kat sini. Right. Kita nak form a new bond kat sini. Okay. The formation of new bond, we need to undergo exothermic. Okay, nak undergo exothermic, nak release heat. Okay, so energy needed is less. Okay, that's why formations of new bond, energy yang kita perlukan kurang. Less energy needed compare to kita nak pecahkan dia punya forces untuk kumpulan tu sendiri. Okay, inside the haloalkane, we need higher energy to break the bond. Okay, same goes to the water. That's why dia bagi tahu kat sini, this is because for dissolving haloalkane in water, the strong hydrogen bond present in the latter has to be broken first. Maksudnya untuk setiap ni, dia kena putuskan dulu dia punya intermolecular forces. Okay, between these two, nak putuskan kita perlukan energy yang tinggi. Okay, maksudnya dekat sini, high boiling point. Okay, compare to kita nak masukkan haloalkane dengan water molecule. So the formations of new bond here ataupun intermolecular forces kat sini, dia punya energy lagi sikit daripada kita nak pecahkan kat sini. So when dissolved in organic, which is non-polar, kalau kita ada non-polar solvent, kita dissolvekan dengan haloalkane, so the intermolecular forces attraction are almost the same as being broken. So dia punya energy needed tu lebih kurang sama. Okay. So for haloalkane to dissolve in water, energy is required to overcome the attraction between the haloalkane molecule and the break the hydrogen bond between the water molecule. Okay, so kat sini. So this one will explain the same, yang sama dengan yang bawah. Okay. Nak putuskan dia punya intermolecular forces between itself lagi tinggi energy compared to kita nak form a new intermolecular forces between haloalkane and water. Okay, that's why dia very slightly soluble saja. Okay. Right. So next properties is density. So the density of liquid haloalkane are greater than those of hydrocarbon of comparable molecular weight. Halogen has a greater mass per volume, meaning that the density, than a methyl or methylene group. Okay, haloalkane density lebih tinggi daripada alkane and alkene. Okay, all liquid bromoalkane and iodoalkane are denser than water. Di and polyhalogenated alkane are denser than water. So given here is the data of the density. We have 3 different halogen group, halogen atom, chlorine, bromine and iodine. So dekat sini depends on the number of the halogen. So kat sini ada 4 halogen, 3 and ada 2. So you boleh nampak dia punya perbezaan in terms of the density. So lagi banyak you punya halogen atom, so the density lebih tinggi. Okay, lebih tumpat daripada air. Okay. So next is the chemical properties of the haloalkane. So the high reactivity of the haloalkane can be explained in terms of the nature of CX bond, which is highly polarized covalent bond due to the large difference in the electronegativities of carbon and halogen atom. So kita hanya tengok dekat CX bond saja. Terus kat sini kita nampak dia punya difference in electronegativity. So the halogen is more electronegative than carbon, okay, and tends to pull the electron away from carbon. Okay, since carbon partial positive, halogen is partial negative. So different electronegativity, bond dekat sini akan pecah secara heterolytically. So these two electron will move to the more electronegative atom, which is X lah, yang ni. Okay, full headed arrow, bukan bagi dekat X. Okay. Halogen gains a small negatively charged, which is partial negative, and carbon a small positively charged, partial positive. So X carries partial negative charge and carbon carries positively charged. Okay. So carbon with positively charged, which is electron poor, kurang electron, is an electrophile. ataupun kita panggil sebagai carbocation, carbon with positively charged. And it attracts electrophile, which is electron rich. This makes halogen atom, which is X negatively charged, easier to leave as X negative. Okay, so the carbon halogen bond strength decrease in order of going down the group. So the bond strength berkurang daripada atas ke bawah lah, menuruni kumpulan. So we have fluorine, chlorine, bromine, iodine. Okay, instead of selain daripada bond strength, dia punya electronegativity pun berkurang daripada fluorine, chlorine, bromine and iodine. Okay, so apa yang different is the polarizability. Kalau polarizability menuruni kumpulan makin tinggi due to the size. Okay, size iodine lagi besar daripada fluorine. Okay, polarizability yang bawah lagi tinggi compared to yang atas. Okay, so carbon halogen bond get less polar, longer and weaker in